Awesome. We'll get started in about a minute. Cool. Let's get started. So hello, everyone. Welcome to Coding 101. This is a kind of a workshop that serves as an intro to programming using a programming language called JavaScript. This is actually the first DEVS event for the year. It was meant to happen in person. Unfortunately, due to kind of the COVID situation, we had to move it online, but that is all good. We have heaps of helpers here. If you guys need any help, feel free to kind of post a question in the chat, or we have like a canva.live link. And if you enter that code, you can kind of ask questions anonymously, and then we can go through that as the host. Cool. The people who are presenting is going to be me. My name is Alan. There's also Simon and also Kay. They'll be taking the latter half of kind of the workshop. Sweet. So kind of before we get started, a huge shout out to our sponsors, our gold sponsors, Potentia, Centrality, and Atlassian, and our silver sponsors, Serato, Nintex, October, Zero, and Canva. Without these sponsors, workshops like these wouldn't be able to happen. So a big shout out to them. Cool. I'm going to start this kind of, I'm going to start this kind of workshop discussing what programming is. Now, programming usually starts with a problem. Now, this problem could be, hey, I want to make a website, or I want to make a game, or say I want to add like 20 million numbers together. Whatever that problem is, you've identified it, and you realize that, hey, a computer would be really good at solving this type of problem. Sometimes it's just necessary for a computer, in the case for like a website. And in order to communicate with a computer, you realize that you need some type of language. And this is where programming languages come in. Using a programming language, you can kind of write all the instructions required to solve that problem, give it off to the computer, and the computer gives back some output. Cool. So there is kind of heaps of programming languages out there, but the one we'll be learning today is JavaScript. And JavaScript is a programming language. It is primarily used for scripting kind of functionality for websites. So for instance, this website that I'm currently on is called Canva. And just like every other website, it uses JavaScript under the hood to do kind of certain functionality. So for instance, if I click the back button, it goes to the previous slide. If I press the forward button, it goes to the next slide. All of that is done by JavaScript behind the hood. But kind of just because you can use it in the browser doesn't mean you can't use it anywhere else. So there are kind of ways to run JavaScript outside the browser using JavaScript runtimes like Node.js. If you want to set up Node.js on your computer, all those instructions are within the prerequisites, but that's not necessary for this workshop. Cool. Kind of another great reason to learn JavaScript. It's actually the most popular programming language, according to this Stack Overflow survey from last year. So yeah, if you're not convinced enough yet, here is kind of the stats. Hopefully by now you'll think that JavaScript is a great language to learn as a beginner. Awesome. The first thing we're going to do is actually kind of get familiar with the environment that we'll be working in today. And that environment is called StackBlitz. It allows us to run Node.js on a browser, which is typically you don't do. So let's actually go to this website, stackblitz.com. Let me make a new tab. Go to stackblitz.com, and you would see, oops. screen that looks something like this. Now, if you were logged in, it would look slightly differently. But kind of the button you have to click to set up our environment is this button here, Node.js blank project. So you can go ahead and click that. Once you do that, it'll set up this environment where we can kind of write JavaScript. The first thing I want to do in this environment is actually close this side panel here because we don't need it. So we can click this close button. That will just give us more space. And I'm actually going to zoom in just for the sake of making you guys see clearly. Cool. Now, the next thing I want to direct your eyes to is this kind of side panel here. And this is where all the files that we'll write or view will live in. Now, in this case, we only have one file that we're interested in, and that's called the index.js file. JS meaning JavaScript. And this is where we're going to be writing all of our JavaScript code. Now, this package.json file is something you can ignore for the purposes of this workshop. In fact, you can actually just delete it by clicking this rubbish icon. It says I just want to delete. OK. Sick. Awesome. So that is the Files tab. And then we have the actual editor. So if I double click index.js, this should already be open. But you can see that this is just a normal text editor, and you can write letters as you would. And you can already see that there is some code here. Now, this first line of code isn't actually kind of code that the computer kind of executes. This is just comments here for us to read. So this just tells us that if we want to run the program, we have to use this command, node index.js in the terminal. Cool. And the kind of second line here is a console.log statement. We'll go into what that does in a bit. But kind of the last place I want to introduce is this terminal here. And this is where you actually run your JavaScript code and see output. And let's actually go ahead and run this file, this index.js file. And we can do that by simply doing what the instructions tell us. You write node, and then a space, and then index.js, which is our file name. And if I click enter, you can see some output on the screen. And you might be wondering, hey, where does this output actually come from? And another thing you might be wondering, does this output happen on every kind of time I run the program? Well, this hello Node.js line here is actually coming from this line of code up here. And so you can think of this line of code as saying, hey, could you please log or print whatever this message is onto the console? And you can think of console as another word for the terminal. So in this case, it prints hello Node.js version, and then it does some magic behind the scenes to get the actual version number. But we won't worry about that for now. Awesome. So that is kind of an introduction to the editor. And we'll actually go back to the slides. Give me a second. Sick. So we're going to be starting to look at fundamental programming kind of concepts, starting with variables. Now, a variable is simply a container that holds any type of data. Kind of the different parts of a variable, you can set it a value, and you refer to it by its name. Now, I represented a variable in this diagram here as a box. Now, this box has a name called greeting word, and it also has a value that you can put inside it. In this case, the word hello. Here's another example. I've created another variable. It has the name my bank balance, and it has the number 10 inside it. Now, you might be wondering, well, why is this useful? Why don't I just use the word hello instead of putting it in a variable? Well, variables are really useful to kind of hold data and manipulate that data kind of over the course of your program. You'll see kind of why it becomes useful like later on in the workshop as you kind of write more code. Awesome. Next, we're going to learn about is how do we write these variables in JavaScript. We create variables using the let keyword. So going straight to the examples, you can see that here we have a line of code. And in order to create a variable, we first write the let keyword. And then after a space, you give the variable name. And then using this equal sign, which says, hey, I want to assign this variable this value. In this case, the word hello. As another example, here we have, again, another variable. We start the line with let, and then we give it a variable name, in this case, bank balance. And we're assigning it the value, this huge number, using this equal sign. Now, the equal sign just means, hey, I want to assign this variable this value. Sick. So one thing you might have noticed before is that we kind of write these variable values slightly differently depending on the type that they are. So for instance, in the previous example, we wrote this word, but we're writing it differently than this number. This word has quotation marks around it, while this number doesn't really have anything. You just write it as a number. And that's because there are different variable types, and you kind of write it out differently. So the first one we look at is a string, which could be a word, it could be a sentence. In essence, it's just a sequence of letters. And the key point to kind of note here is that you have to use quotes to kind of write them. So for instance, here is a string, which is a random jumble of letters. Here's a string that's just a single character. And here's a whole ass sentence. Cool. The second data type we've already seen is a number. Now, a number is simply what you're familiar with. It's a whole number or a number with decimals. So as an example, the number 1 or the number 3.1415, or this really big number. Now, in other programming languages, they may distinguish between different types of numbers. So for instance, a whole number and a number with decimals. In JavaScript, it doesn't matter. JavaScript just sees it as a number, which is great for, for kind of our user experience. Cool. The last data type we'll be looking at is a Boolean. And a Boolean is simply a true or a false value. And you might be wondering, hey, why would that ever be useful? Why would I need to have a type for true or false? Well, it actually becomes really useful as we learn about conditions. So to give you as an example, if you wanted to kind of represent the data on whether or not, is it raining outside, then that kind of variable needs either true or false. True if it is raining, false if it isn't. And so it becomes really useful in programming as we kind of learn kind of if statements and conditions. Cool. Just before we move on, we'll actually just experiment around with variables in our stack list editor. Cool. So hopefully you have this open by now. And I'm just going to delete everything in here. And let's create our first variable. Firstly, we start off the line with the keyword let. And after a space, you give it the variable name. So let's call it greeting. And then to assign it a value, you use the equal sign. And then you give it the specific value that you want. In this case, I want to put a string with the sentence hello world. Sweet. So if I were to save that, you can see that a semicolon appears at the end. That doesn't matter. It's kind of the same thing. If you kind of delete that semicolon, it just automatically creates it when you save. That's fine. And if I were to run this program using node index.js in the terminal, you can see, well, first of all, nothing is printed out. And that's because, well, while we have created this variable and we've given it this value, we haven't done anything with that variable. So the next kind of step is, well, how do I output it on the kind of terminal? And we'll reuse that command that we saw earlier, console.log. And this will log something to the console. To actually log out the variable, we first write brackets or parentheses, and then we'll put our variable name. And this will get the value stored in this variable and then print it to the console or log it to the console. So if I save this and run the same thing, you can see that, hey, hello world is printed. Sick. Just for the sake of kind of writing more code, let's create a couple of more variables. Our first one could be to represent a number. Let's call it my age. And we'll set it to 23. Yeah. Oh, right. One thing I forgot to mention is that these variable names need to be one continuous string of characters. You can't put spaces in it. Suddenly there's an error. So if you want to use kind of, well, split kind of words up, you have to use either an underscore or a dash. Actually, not a dash, just an underscore. Sick. So we could console.log that out. And let's create another variable to like implement a Boolean. So just call it, is it raining? And we'll set that to false because at the moment it's not raining here. We'll console.log that out. And you can run node index.js. And you can see, hey, 23 is printed because that's the first variable value, and false is also printed. Awesome. Sick. Let me go back to the slides.
Sorry. When I save it, like the semicolon doesn't appear. Is that okay? Or do I have to add?
Yeah, that's all good. That automatically appears. In fact, in JavaScript, it doesn't matter if you include that semicolon or not. It's completely optional, and it makes no difference to your program.
Cool. All right.
Sick. Cool. The next thing we'll learn about is maths operators. So this is probably kind of stuff that you already know about. Just as in maths, we can do the same operators on numbers in programming in JavaScript. So for instance, for the addition operator, use the plus sign. For subtraction, use the minus sign. Multiplication, use the asterisk. Division, use slash. For modulus, which is probably something you haven't heard of before, use the percentage sign. And to give a summary, the modulus is simply the remainder after you kind of divide two numbers. So for instance, 6 divided by 2 is 3, remainder is 0. So the modulus would be 0. And lastly, powers, which is done using this double asterisk sign, not to be confused by the single asterisk sign for multiplication. Cool. So running through this example, here I've created a variable. I've assigned it the value 1,000. In this case, it's multiplication times 5. So that's 5,000. Here's another variable with a value 200. And this is something we haven't seen before. This is actually the reassignment of a variable. So we're taking that existing bank balance container, that variable, and we're assigning it a new value. In this case, we're assigning it the old bank balance, which is 5,000 minus 200. So that will be 4,800. And then kind of going down, we just do some division on it. Awesome. So this is kind of an activity for you. Here's a bunch of code. And my question to you is, what value does this what variable have? The first person to kind of get this and post it on the chat or say it out loud will win a DEVS shirt. So I'll give you kind of like a minute to kind of try to figure it out. Awesome. Someone's already figured it out. Yes, the answer is 4. Congrats. Let me check. Vinny. Oh, I forgot. I was meant to switch to the next slide. I was meant to show this. So yeah, it is. The answer is 4. To kind of walk through. Oh wow, that is laggy. To walk through why it's 4. First of all, you create a variable with the number 2. Here's another variable with 1 plus 2 using that previous variable. That's 3. Here's another variable, 2,000. In this case, we're doing 2,000 times 3, so it's 6,000. Then lastly, we're doing 6,000 divided by 3,000, which is 2. And this is the power operator, and 2 to the 2 is 4. Awesome. Cool. Yeah, I will be taking a quick 1-minute break as I answer a question. So it seems as if people have difficulty opening the terminal. So if control backtick doesn't work, my suggestion would be to kind of make sure that you have a Node.js project running. If not, it could be that you're zoomed in too much. Actually, I don't think that's a problem, but make sure that, oops, you are not closing the terminal using control's backtick. So the backtick is the number next to 1. Awesome. If you can't get that still working, feel free to message either Kay or Simon, and I'm sure that they can kind of help. Awesome. The next thing we'll be learning about is comparisons, which is kind of an application of Booleans. Now, comparison is comparing two values. So we learned about values before, and this time we want to do kind of certain comparisons on them. So for instance, if you want to check if two values are equal, then you can do so using the triple equal sign. For instance, hey, is the number 5 equal to the number 5? Well, obviously that's true. If we have on the next example, the not equals operator, and we're checking, is the word yo-yo not equal to the word not yo-yo? And that's, again, obviously true. And here we have two variables, x is 5 and y is 3. And in this less than operator, it is checking if x is less than y. So is 5 less than 3? Well, obviously not. And so that would be false. Now, kind of to expand on this kind of conditions and, not conditions, I mean comparisons, a really useful kind of aspect of it is when it comes to conditional statements. So far, kind of all the code that we have written will execute no matter what. And sometimes we want to execute code based on a condition. So to kind of give a real life example, we make a decision based on the condition that, for instance, is it raining or not? So if it's raining, we do some actions, for instance, stay inside. If it is sunny, then we'll go outside and play. So we're making that decision based on the weather, and if it's equal to either rainy or sunny. So we can do this in JavaScript using a if, else if, and else statement. And it allows us to execute kind of different code based on a particular condition. Cool. So this is a whole lot of new syntax, but we'll go through it together and hopefully it'll kind of make sense. So a if statement is used to execute code based on a condition. So we start with the kind of keyword if, and within parentheses, so these brackets here, we write our condition. And if that condition is true, so in this case, is weather equal to rainy, then we execute the code in between these curly brackets. So if it's true, it will execute console.log stay inside. So kind of running through the example, here we have the kind of variable called weather, and we are assigning it the value sunny. And then we have an if statement, is sunny equal to rainy? So in this case, it's obviously false. So this bit of code here will not get executed. Instead, it goes to the else if statement, which kind of does the same thing. It just checks, hey, is weather equal to sunny this time? And obviously that's true because we have the variable set to sunny. And so the code that's in between these curly brackets will execute. So in this case, it will execute console.log, let's go outside. Now this last else statement, it doesn't have a condition. And you can think of it as a catch-all. If the previous if statements fail and else if statements fail, then the else statement and everything inside it will execute. Awesome. Let's actually just run through an example here. Sweet. So let's write out some if statements. Again, we start with the keyword if, and then within parentheses or brackets, we'll write our condition. So my condition is, hey, I want to check if the variable my age is less than 15. Actually, let's do less than 20. And if it is, I want to execute some code. So we put that code in between curly brackets. And the curly brackets is living next to your P key on your keyboard. And then we can write code inside these curly brackets. So for instance, I want to write, hey, console.log. I am a teenager or a child. Because if my age is less than 20, then yeah, I'm either a teenager or a child. Let's do another kind of check, this time using an else if statement. So within, we write else if as two kind of new keywords, and then within brackets, we'll check this condition, which is my age is greater than, say, 60. And within curly brackets, we'll write our code. So we'll say console.log, I am retired. And then kind of if these two conditions are not met, so they're both false, we want to write some code also. So we can do that using a else statement. So note that the else does not have a condition. It's simply the keyword else. So we can write console.log. So in this case, it must be that my age must be between 20 and 60. Awesome. So let's go ahead and actually run the code using node index.js. So you can see that, oops, that between 20 and 60 is printed. Just a question in the chat. What is the semicolon for? The semicolon just indicates the end of a line. In JavaScript, it doesn't matter if you have the semicolon or not, but due to the nature of stackblitz, it forces you to add a semicolon for some reason every time you save. But yeah, you can just completely ignore it. It isn't to print things. I think that's a MATLAB. Second question, is there no separate float variable? No. So in JavaScript, there's only a single number variable, and that encapsulates both floats, so those are decimals, and whole numbers. Also, so yeah, coming back to a if statement, we found that it's between 20 and 60 because my age was set to 23. Cool. Let's actually kind of change this variable so that it prints something else. So let's make it 15. And we know that 15 is less than 20. So this first if statement should execute. So let's write node index.js. I can say, hey, I'm a teenager or a child. And let's lastly, just for the sake of doing it, let's write 65. In this case, this first condition will fail, but the second condition will pass. So write node index.js and says, hey, I am retired. Awesome. I will zoom in a bit. Cool. So running through kind of the final slides before we take a break. Sometimes we want to kind of have more complex conditions. So we want to check more than a single condition like we've done previously. So for here, in this previous slide, we only checked a single condition. So in this case, is weather equal to raining? But sometimes we want to check multiple. And we can do so using conditional operators. And the first one we look at is the AND operator, this double ampersand. So if we want to check if the weather is sunny, and in this case, we also want to check if the month that we're in is less than 2. We can use a AND operator to check if both of these conditions are true. So going through the examples, that'll probably make more sense. In this case, it's sunny and the month is January. So this first condition is true because it's sunny, and the second condition is true because January is the first month. And since both of them are true, this will evaluate you true. So if you kind of read this out in English, this condition says, if the weather is sunny and the month is less than 2. So in this case, in the second example, the weather is rainy. So this first condition fails. And it's because it's false, this whole kind of complex condition is resulting in false. And that's why this is false. Kind of another conditional operator is the OR operator. And we write it using a double straight line. This is kind of the key that's next to the curly brackets. The OR operator checks if either or of the kind of conditions are true. And if it is, it will return true. So running through the examples, in this case, weather is sunny and the month is January. So since both of these are true, it will return true. And in this case, it's raining. So this first condition is false. It's not sunny. And the month is less than 2. Yeah, and since January is less than 2, this condition here is true, and so the whole condition is true. We won't be using much complex conditionals in this kind of workshop, but I just wanted to kind of let you know that they're there. Cool. That is the end of my portion of the kind of content. I'll give it to Simon to kind of resume, but first we'll kind of take a quick kind of 2-minute break. In this break, you can kind of ask questions about things that you're completely lost about, and we can try to answer them to the best of our abilities. Cool. So it says that, so what question is, my file is not executing. So one thing you have to make sure you're doing is save the file. So you can either press Control S, or you can click the save button up here. Another kind of question is, how come the string changed from these double quotes to single quotes? And that's again because of the quirk of stack blitz. It has an automatic formatter that just changes these things. It has no effect on the functionality of the actual program. In JavaScript, you can use both double quotes or single quotes. They both represent strings. Yeah, hopefully that answers the question. Sick. Yeah, I'll pass it on to Simon to kind of go through the next variable type.
Sweet. Thanks, Alan. Can you guys hear me all right? Hello?
Yeah.
Okay, sweet. So yeah, just before I start, I will share the link of all the example codes in my part, and you guys can play around with it. Just gonna copy and paste that in the chat. That will be the example code that I'll be using. Yeah, sweet. So as Alan mentioned about variable, that is great. You can use it to store stuff that you want. And here in the context of a fruit bar, you can use orange to store the string value of orange. So that's apple and banana. Yep, but just think about it. What if you have got tons of fruit that you want to store? In that scene, the list of the variable storage will just keep growing. Say you've got hundreds and thousands of fruits, and just imagine how long this list is going to be. So here is just an example of how that would potentially looking like by using like a variable to store each string value. You also need like a whole bunch of console.log statement to print it out. So here's why we need an array. The first question is, what is an array? Well, basically you can think of it as like a shelf that allows you to put all those fruits in. The syntax of an array can be defined in the form of using let, followed by a variable name. And then the equal sign with the square brackets allows you to hold all the values in, and each of the value will separated by a comma. And the way how array works is that it always starts counting from 0. See, you got 7 fruits in on the shelf, and it will only count up to 6. And tell you what, a good programmer always starts counting from 0, except for MATLAB. Yeah, sweet. So there's a couple of cool things that you can do about for array. The first thing you might want to do is to grab the fruit from the shelf. Say you want to grab a banana, you can easily do it by using the index. So I'll just show an example of how you can grab the banana. So here's just the link that I've been sent out with all the example code. In here, we got the array fruits, and then we will just be grabbing the element with index 1, which is banana. So I'm just going to quickly run through this code. We're going to do node array underscore with grab.js, and just whatever file that you are trying to run, it is always node, and then with the file name. In this case, we're running array underscore grab.js. Sweet. So we managed to grab banana. Okay. Great. So the next thing you can do for an array is maybe change a fruit from the shelf to something you want. Say you're a big fan of orange, then you can change the apple to orange. Likewise, you can manage to do that by using the index as well. So just will be fruits square bracket with the index, and then with a equal symbol. And here will be the new value after changing the element inside of the array. And I will run through the Arraychange.js example to show how it looks like before and after changes. So in here, I'll do array underscore change.js. And see in the terminal, it prints out a couple of things. So the array before changes, it's the first, the element with the 0th index is apple. But after we change it here by using the statement in line 13, we change the element with index of 0 to orange. And here's the array, how it looks like after changing it. We can see the first element becomes orange afterwards. Could you zoom in a bit? Yeah, sure. Oops. Yep, is it better now? Okay, sweet. No worries. Yep. Sweet. So the next thing we are trying to learn, how do you add something inside of an array? And you will be able to do it by using the push method. And for the method part, that Kay will cover more in his session, but in this case, we'll just try to learn like a method called push. So slightly different, how do you use like a function or like a method is you have a dot here, and then with push, with the value, that you're wanting to add inside of the bracket. And also the example trying to run array add.js. So here's how the original array looks like. We're just trying to run this code to see if it changes. So we have node array underscore add.js. And we can see from this terminal, the array only has 7 elements beforehand. And then afterwards, we have lemon adding to the end. Cool. So by now, you should be able to do some easy operation with the array. And maybe the next thing that you are trying to do is to grab each individual fruit from the shelf. So that's a very classic way I can think of, is just trying to use the index one by one. In this case, I'm trying to use index 0 all the way up to index 6 to grab the fruit from the shelf. And something like this will just be print out. So we have the classic grab all in here of having all the console log allows you to print every individual item from the array. Let's quickly run through it. Node array grab classic.js. So here's how it looks like. It will print out every item in the array from Apple to BlackBerry. But maybe there's like a smarter way you can do so, which is to use a for loop to allow us to perform repetitive tasks more effectively. And if we take a look at the for loop, it makes up by mainly 3 parts. You got the first part of defining a variable called index and then assign it with an initial value of 0. And the next step, you'll be using a condition to determine when the loop will stop. So in this case, it will stop the loop when it is no longer smaller than 7. And lastly, this part of the code will increase the index by 1 after each loop. So if we look at array grab or smart, here will be how it looks like by using a for loop. Let's quickly run through this code. Array grab or smart.js. So as you can see, nothing too exciting. It does the same thing as the previous code, but it's just how it allows us to achieve more effective outcome from repetitive tasks. The way how we construct like a for loop allows us to iterate through every element inside of this array. So notice that the code statement inside of the curly bracket will execute 7 times in this case, and just allows us print all the way from Apple to BlackBerry. One thing that you might look a bit different from the slides is instead of 7, we're using fruits.length. And here is just like a way how you can use to exactly count up to the elements, the number of elements inside of this array. So it is 7 here, and it's a cool thing that you can do. And now you should be having some good ideas about how to use array and a for loop. And at here, I have can you do index plus plus? Oh yes, just a question from the chat. Yeah, that's a syntax sugar, which is a more concise way, allows you to increase the index. But I'm just writing index equals index plus 1 is a more explicit way allows you to see what's actually happening. And of course, when you become more familiar with JavaScript, you can definitely do index++. They're the same thing. Sweet. So I have a challenge for you. I have an orange lover challenge for you, which I want you to print out a shelf that is full of oranges. And here is how it should be looking like in the terminal. And just remember, you got many ways that you can do it. And it's time to be hacky. Sweet. Let's say for the next 5 minutes, I'll let you guys to crack onto that. Where do we write code in? Yeah, if you look at the link that I've shared with you, I have included a template called orangelovers.js. So you can potentially, that's like a good place to start work with. Yeah, sweet. So I might just bring back the slides. Yep, and let's go. Oh yeah, by the way, if you finish just writing up your solution or your answers, feel free to share your StatBlitz link in the chat so I can click in and just show your amazing code to everyone who attend today's event. And if you have any questions or concern, feel free to message in the chat or speak up if you want to. Oh, sweet. Got someone who. Okay. Sweet. Let's run yours. Right. Grab or classic. Yeah, awesome, Mike. Awesome. 7 oranges. Okay, we got another orange lover coming in. So, node, orange lover, yes. That's awesome. Good stuff. We have another reply here. Lover, yes. Nice work. Sweet, that's really cool stuff. We have another. Orange, lover, yes. Yep, that's correct. Sweet. So yeah, you guys aced it. Very nice. Why are some of the arrays printed out in a straight line, but others are printed in 2D looking grid? So we have some S at the end, making them look like. Okay, so let's go for Kai's solution first. Okay, yes. Yeah. Great job. when exactly do you need to use curly brackets? Okay, so very good questions about when do we actually need to use curly brackets. So we just say we got a for loop. So let I plus plus. Say you got a for loop without using a curly bracket. It will only affect the line statement only below that for loop. Only below this line. Say we got console.log 1, and then we have console.log 2, and if we run through this example, oh, okay, so typo here. Oh, interesting. Okay. You mistype console. Okay, thank you. So if for curly brackets, I think I'm not particularly sure in JavaScript, but I think it's always like a good practice to include it. Sweet. Yeah, let's keep going. It's 5 minutes already. I will answer more questions after my session is finished. I will direct message you. And yeah, okay, sweet. So pretty much that's the end of my part, and I will now hand over to Kay. Curly bracket allows you to write multiple lines of the code in your for loop. Yes. Yes, I think Alan just answered the questions. I think now I'll be hand over to Kay.
Hello. I think Alan, you need to enable the screen sharing. I think I can't see the screen, so. Oh yeah, there you go. Nice. Can you guys see it? And you guys can hear me? Just react in chat. So I'll be explaining functions, and also thank you, Alan and Simon, for the presenting previous slides. Functions are pretty hard concept to understand, but I think you got this. If I can understand, I'm pretty sure you can do too. So function is just a chunk of code or block of code, what you've just learned. Let's say for loop arrays, you can put that in the function, and you can use that over and over again. Also, it can take inputs and output something. As you can see in the example below, right here. So I have the button there right here, and he has a function called make drink. So in this case, you give a cup that's your input right here. That's a cup, and the button that calls the function make drink, and outputs the drink. So this is your output or the final product. So make drink has a set of instructions on how to make this drink. And so every time you call this function, so every time you call this make drink function, the set of instructions will be triggered. That's inside the make drink function. But why do we want to use it? As I mentioned before, you can call a function as many times as you want without writing the block of code or the same code over and over. That's pretty nice and neat, but there's more than that. If you have bigger problems or projects like Mario games, you want to break it down into parts. So instead of having a big chunk of code that controls the movement of character. You can break down the code into move up function, move right, move down, and move left. So as you can see here, if you have Mario, you can break the movement into different functions. Let's say move up, move right, move down, move left. In this way, the code looks more readable and neat, and also your supervisor won't hate you. So how do we actually define a function in JavaScript? So use a function keyword to tell JavaScript, so this one, function keyword, that you're gonna write a function. And next to that, you have the name of the function, and you have the brackets next to the name of the function. I talk about this bracket later. And after that, you have the curly braces, and inside the curly braces, you have the set of instructions or the code. So in this case, it's console.log bboop. After that, you can call this function as many times you want. So if you call this function once, it's going to output bboop in the terminal. So how do we take inputs and output from the user? So input, as known as parameters, goes inside the brackets right here. That's next to the function name. So next to the function name, you have the bracket and the input or the parameters. And the return keyword declares output, so right here. So in the example below, or what I'm pointing at with the cursor, the complete sentence is getting called. You need an input. So when it's getting called, you need an input, which is coding. This means the sentence variable inside the function, this one, it's gonna have a variable of I like coding, and it's gonna return it or outputs it. So the completed sentence, that's a variable, it's gonna have a variable of I like coding. It's pretty complicated, but I hope you understand it. So if I console log in the terminal, this completed sentence, it's gonna print I like coding. To make everything clear, I just do a small demo. So open up Stackblitz. I make my profile for this demo. Okay, profile. Oh, I think Simon forgot to explain about object. So object is like a key and pair. So as a name, this is a key, and that's my name. It's okay, and it's all good, Simon. And I have my age, which I'm 19 right now. So objects are pretty easy to understand. So if you want to access this value inside object, let's say I can go console.log. Okay, profile.name. Sorry, I'm explaining about object. Is Simon forgot to explain about it. But so if I learn this chunk of code, node index.js, the K is going to print it. It's because I'm accessing the name of from my profile, which is K. So you can get age too. So if I do this, the 19 is going to get printed out. And also you can do, if I want to change my birth year, I can access it by .h, and then let's say I turn it 21. Now the K profile should have the property age that's 21. So if I print it in the console, I need to print it first. Console.log. Okay, profile. Index.js. Yeah. Now I have the 21 as my age. Okay, nice. Let's delete this. Now I'll be talking about functions. So to declare a function, you need a function keyword. And what I want to do here is I want to update users' age. So when the birthday comes or something, I can update my age. So update age, it takes two parameters or the input. So one is profile. The second one is the age you're turning into. So let's say it's new age. And you need a curly braces like this. And to access the user's age, you need to go profile.age and assign the new age, which is new age. So if you call this function with my profile, update age, okay, profile, let's say I turn 30 for some reason, and let's console.log k profile. Node index.js. Now I have the age of 30. Yeah. Let's make other function using return keyword. So function, let's call it find age gap, let's say. And this function is going to take two parameters, which is profile1 and profile2, because you want to compare the user's age gap. So profile2, and you need a curly braces, and let's declare a variable code age gap. And to get the age gap, you need a age profile1.age minus profile2.age. And I don't want this age gap to be negative. So if let's say profile1 has an age of 20 and profile2 has an age of 21, then age gap is going to be -1, which doesn't make sense. So I'm going to have an if statement. If the age gap is less than 0, this means negative, right? I'm going to set age gap. I'm going to times it by -1, so it turns positive. And finally, return this age. Return age gap variable. So to test this function, I need one more profile. So I'm going to put Alan profile. And it has a name, Alan. Age. Wait, Alan, actually, I don't know your age. Wait, how old are you? Sorry. Let's see here.
21.
21. Okay, cool. 21. So it's 21. And let's call this function. I'm going to have a new variable called age gap, and call this function called find age gap, and put my profile and Alan's profile, and let's console log it to the terminal. Age gap. Now node index.js 2. So I'm 19 and he's 21, so the age gap is 2. I hope that makes sense. Now I have a small project, or the question you need to do. Write a function that takes two lists of numbers as input and returns the total value of all the numbers added together from the list. So the list one, and here in this case have 1, 3, 5, and the second one has 2, 4, 6. So added all together, it should print out 21 in here. So go on to make new Stack Blitz project, and yeah, as Alan said, just copy the link to the Zoom chat. Yeah, the answer to the Zoom chat. And this should maybe take 3 minutes, 4 minutes to answer. So yeah, and in the meantime, I'll answer some of the questions I got, or if there's any questions. Let's see. And the last section, why we using instead of equal in the let section. Oh, you mean in the object? If it's so, yeah, you have to use colon. Is that the right word? I forgot. But yeah, double dot to assign the value. So in this case, name has a value of k. Hope that makes sense. So oops, that was the answer. Sorry. Everyone can just paste in the stuck bits link if everyone's done. All right, time's up. So I explained the answer. Was shown the screen a couple times before, but it's my bad. So the answer should look like this. So I used 2 for loops from the before what we learned. So you're gonna declare a new variable called total value, which equals to 0. That's the sum from the 2 lists. And you're gonna define. Are you gonna use a for loop? So index 0. You want to run this for loop for the length. So if the length of the list 1 is 3, then you want to run it 3 times. So that's what it's doing here. And index plus 1. So to increment the value for index. And to other value, total value equal total value plus list 1 index. So you're going to sum up every single value in the list 1. So in this case, 135. So it's going to add 0 plus 1, 1 plus 3, 4 plus 5 in that order. And the next for loop, it's basically the same thing, but with list 2. And you're going to return the total value, which should be 21 in this case. And you can put any list here. So it doesn't have to be 135 or 246. It can be 135, 6, 246, 8 or something like that. And it should always print out the right answer. Yep. Total should be 50. I mean, it's 21, isn't it? If I can do the math. So 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 2 is 11, 11 plus 4 is 15, 15 plus 6, 21. Yep. So I'm going to talk about third-party libraries. So JavaScript offers many third-party libraries to do variety of things. In the past, people struggled with common problems like making websites, animations, and a game, and many more. Nowadays, there are many libraries that helps to solve these problems. The image shown below are just some of the popular libraries like React for making website, 3JS for 3D modeling, or 3D model rendering, Framer Motion for animation, and so on. And this library is made by mega brain people or the smart people. Like Angular is made by Google, and React is made by Facebook. Now my turns, I think it's over. I pass it to Alan for the next slides.
Thank you. Okay, can you guys see my screen? Awesome.
Yes,
Sweet. Just before we kind of move on from there, I do want to take a step back and go over objects, which Kay kind of demonstrated before, but I do want to kind of explain kind of the theory behind it and why it's kind of useful to have. So an object is simply kind of a collection of related data and functions. This will make a whole lot more sense in the example. So in this example, we have kind of two people, and two people have different kind of properties that we want to store as a variable. So for instance, they might have a name, they have age, and in this case, they have a height. Now these are kind of two kind of common people, and they have common properties. And often, before this, there's kind of two ways we can go about kind of storing this information. We could create separate variables for each of these different properties. We could make a string variable to hold the person A's kind of name, and then his age, and then his height. And then we can make another kind of set of 3 variables to do kind of the same thing for the next person. But it's great to have kind of a common structure to all of these kind of related data and store it all in a single place. And that's where objects come in. Cool. So objects allow you to store kind of data in one place instead of storing them in a separate variables. So how do you write them in JavaScript? To translate kind of this data here to a object, we again use the let keyword because this is still a variable. There's no difference from the other things we learned about. It's still a variable, and then we give it a variable name. And then here's kind of new syntax that we haven't seen before. The curly brackets in this case is different from the curly brackets that we saw before. This kind of curly brackets is to declare an object and all of its properties and values. So within these curly brackets, we write the key. So the key defines the kind of what you refer to a piece of data by, and then you give it a value. And instead of using an equal sign, we're using a colon here. To separate kind of the different keys, we use a key values, we use a comma, and then we write the next set of them. So age, colon 18. And then again for height. Kind of the whole point of this is that you have a standard way of saying, okay, this object has this bunch of properties, and you can do kind of operations based on that. I won't go through an example because Kay kind of went through an example before, but this becomes kind of relevant for our kind of mini project that we'll be having, which I'll quickly change the slides to. Give me a second. Cool. So the project here is Pac-Man. So we'll be completing some functions to complete this Pac-Man game. So the two functions that we'll be implementing is handle Pac-Man eat pill. So this is what happens when Pac-Man touches a specific pill. And also handle ghost eat Pac-Man. So this is what happens when a ghost touches Pac-Man. So we have written a whole lot of bunch of code for you, and we'll only be implementing these two functions for the sake of time. But before I kind of go to the starter project, I do want to explain that, explain the third-party library we're using. So we're using a third-party library called Phaser, and Phaser is a JavaScript library that allows you to kind of make games within the browser really easily. They have a whole bunch of documentation which goes through their kind of architecture and how you go about making these type of games. And we'll be kind of reading through it as we implement the project. Cool. Actually, yeah, I'll go through the final slide and then go to the starter project. So one kind of key aspect of Phaser is that they use objects to represent the different entities within a game. So as we saw in the screenshot before, we have these different kind of pieces. We have Pac-Man, we have the ghosts, we have the pills. All of those things are represented by a sprite object. And just as we learned before, these sprite objects have key value pairs. So for instance, it might have a body key. And that kind of body key controls all the physics that have to do with a game object. It has a destroy key, which is actually a function, and that kind of destroys the sprite. It has a set visible key, which will set a game object to invisible or visible, and also has a anims key, which you can access to kind of play certain animations and so on and so on. We'll actually read through the kind of documentation to get a better understanding of what each of these keys do. But kind of the key point here is that these are just objects. What I kind of showed you before, they follow the same structure, but they're a bit more complicated due to the fact that they might not contain the same kind of simple value types that we are familiar with. So in this case, body is itself itself an object. So it's an object within an object. And in this case, this is a function. So it's a bit more complicated, but it kind of abides by the same principles. So let's kind of get into the starter project. And to access it, in the README, if you scroll all the way down, you'll see a kind of link here, project stack blitz starter. And if you click on that, I'll likely copy this to the Zoom chat. If you click on that, it will redirect you to a link for a Stack Blitz project, which you can kind of hack on your own. So here's what kind of shows up. I'll post this in the chat. And you can kind of move. So basic functionality for moving is implemented. But you can note that Pac-Man is not eating any pills. And one other thing is if I zoom out, the score here is not updating as I eat the pills. And I have this lives thing here, which will also be modifying. And if I go run into a ghost and kill myself, if he comes to me, you'll see that, well, I don't die. I just go through him. So those kind of functionalities is what we'll be implementing. And it'll be handled by these two functions here. So if I zoom in a bit, function handle Pac-Man eat pill and handle ghost eat Pac-Man. Now, before I kind of get started implementing this, I do want to talk about the entire code base as a whole. Now, it does kind of feel overwhelming to look at all of this code and not understand anything that's going on. But I do want to reassure you that it's not really that necessary to understand all of this code, because as Kay said before, functions allow you to kind of abstract away details. So for instance, this load images function, by its name, you can kind of understand that it loads images. You don't really need to know what actually goes on inside this function. You can just read the function name. For instance, the setup game function, it sets up the game. It does a lot of complicated things. You don't need to worry about it. It just sets up the game. And kind of so on. The only kind of functions that we'll be worrying about are these two functions. And I guess this kind of demonstrates why functions are such a great concept in programming. It allows you to split up functionality, focus on a specific task, and kind of go from there. Cool. I will open up the documentation for Phaser first. Give me a second. So I go to this link. This is kind of the documentation for Phaser. We won't be reading much through it, but it's great to have kind of at hand. Cool. So let's start implementing the first function, which is handle Pac-Man eat pill. So this is what will get called when Pac-Man touches a pill. So in our case, I've kind of commented what we want to happen, and we'll go ahead and try implement that. And so the first thing is I want to increase the score by 5. And so I have this variable score here, and I should be increasing this every time I touch the pill. So if I kind of apply what we've learned, we can reassign the score variable a new value. So score is equal to score plus 5. We're taking this box score, and we're assigning it a new value, score plus 5. And if I save that, you can see that if I zoom out a bit, my score is dramatically increasing by the second. And to kind of understand what's going on here, as I kind of mentioned before, this function, handle Pac-Man eat pill, gets called every single time I touch a pill. And because of the fact that I'm always touching a pill in this case, and I'm not destroying it, then the score keeps increasing by 5. What I really want to do is destroy the pill once I've added that score. And we can do that using a method or a function that Phaser kind of provides. So here I have, as a parameter, a pill game object. Oops. I have a pill sprite object. And if I go through the Phaser documentation, if I go under game objects and click sprite, you don't need to go through this yourself. I'm just going to try to link you to the right place. Then you can find all of the different keys that the Phaser sprite object contains. It seems overwhelming, but we'll only be using like a couple of things. In this case, I think it is called destroy. So in this case, it destroys the game object, which is exactly what we want it to do. So we'll go back to our code. And we'll call that destroy method. And how do we do that? Well, we first write the object name, which is called pill. And then we'll write the dot to access that specific property. And then we'll call the destroy function, just as kind of K went through. If I save this and I refresh this page, you can see that every time I touch a pill, it disappears, it gets destroyed, and I'm also increasing the score by 5. Awesome. So that's the first kind of function implemented. And I'll kind of be moving on to the second function, which is handle ghost eat Pac-Man, which is a bit more complicated. So if you want to refresh the page, you simply go to this link up here and then just press enter. I think you can also press this button. Oh, yeah, I don't think the button works for some reason, but you can just click on that link. Cool. So we're gonna implement the next function, which is handle ghost eat Pac-Man, which is called every time I touch a ghost, or not me, Pac-Man touches a ghost. And I've kind of, again, commented the different steps that we're taking. The first thing we want to do, how do we save the code? So you can either click the save button here and then refresh the page to see your changes. By the page, I mean this specific link here, not the actual web browser link. If you want to kind of have a copy of this on your own computer and not on Slack Blitz, the save button, simply press Control S, and that would hopefully do the same thing. Yeah. Right, yeah. You could click the fork button to create your own copy, and then you can click save from there. Okay, so let's go through the different kind of steps here. The first thing we want to do is stop Pac-Man. And again, this is something that Phaser provides. They take care of all the physics. So in a sense, we have to call one of their methods. Let's go back to the Phaser documentation. And I'm just going to go to the specific property that we need, which is called .body. And then, oops. And then clicking to the arcade body link, you'll find a property called setEnable, which sets the body's enable property. That's not really a useful definition. If I go to the enable, it just says whether this body is updated by the physics simulation, which is kind of exactly what we want. We just want physics to stop for Pac-Man. We just want him to stop. So we can use that property, writing Pacman.body. So we're accessing the body property. And then inside this body property, which we know is an object, we can write .setEnable. and then false. So this will stop Pac-Man. Kind of the next step is making all the ghosts invisible. So kind of a parameter that was passed into the handle ghost eat Pac-Man is the ghosts. It's a list of ghosts. So we can actually go through all of the ghosts and set their visibility to 0. So we can do that simply by using a for loop, as we've kind of talked about before, using the for keyword. And within parentheses, we go through kind of the 3 steps of creating a for loop, which is first creating a variable to represent the index. So I can call this variable anything I want. I'll call it I, and I'll set that to 0. And then separated by a semicolon, I will kind of write the condition. So in this case, I want I to be less than ghosts.length, which is the number of ghosts there are. And then I'll increase this index by 1, which is that plus plus, or you can do I plus, I equals to I plus 1. Cool. Yeah, so within this for loop, I want to kind of make all the ghosts invisible. So you simply do that by writing ghost. Oops, this is meant to be ghosts with the S. And then access the specific ghost using the index. And then I'll set the visible property using the set visible method to false. And the kind of, let me try kill myself. And oh my gosh, this, wow. Cool. So Pac-Man stops, ghosts all disappear. The next thing we want to do is play Pac-Man's death animation, which I don't want to go to the back to the documentation and find the method, but if you trust me, it will be in the anims property. So we can do Pac-Man to access the Pac-Man object, find the key, anims key, and then we're calling a method called play, which will play a death animation. And the specific death animation we have to pass in as input. So as a string, we pass in the string die. That will play the death animation. So if I go back and try kill myself, you can see, hey, the death animation is playing. And finally, the last thing we're going to do is decrease those lives we have by 1. So you can see that there's a variable called lives up here, and we'll decrease that by 1. So we can do lives is equal to lives minus 1. Awesome. Now, one final thing I'm going to do, just for the sake of kind of introducing a new concept, is check if we have 0 lives. And we can do that using an if statement, because that's simply a condition. We can say if lives is equal to 0, using that triple equal sign, we can write some code. We can say console.log, I'm dead, because I'm dead. So yeah, that is a basic if statement, just to kind of apply an if statement for the sake of applying it. There is no game over logic, so you'll see the game stop. But hopefully you kind of got that point across. Awesome. So that is kind of the 2 methods we have completed. And I'll go back to kind of the final slides. Oops. Give me a second. Awesome. Kind of the thing I wanted to introduce at the end of the workshop was that we do have a competition for this workshop. And the competition is all about extending the Pac-Man game that I just introduced. So there's kind of 4 kind of potential steps to this competition, but feel free to just do the steps that you can. It's kind of going through this. One of the activities is, hey, can you make the ghost go 10 units faster every time Pac-Man eats a pill. And that should be like a one-line thing. So that counts as one entry. Second, we have kind of an if statement introduced, which is if the ghost speed, actually, I want to explain the solution. We cap the ghost speed at 500 to make sure the ghosts are not too fast. And then thirdly, which is a bit harder, we have functionality such that if Pac-Man eats between 5 and 10 pills, he should be able to eat ghosts. And to kind of assist with all of this stuff, I've written a little bit of documentation in the GitHub to try provide hints for that. And the last one is experimentation. So if you want, you can implement anything related, I guess, in this Pac-Man game. And depending on like the complexity of your solution, you'll get 1 to 3 entries. And so what do these entries mean? Well, that kind of comes into the prizes. If you do kind of complete all of these different tasks and you do it the fastest, then you'll win a Logitech mouse, gaming mouse. Additionally, there's another prize called for the Google Nest Mini, such that like any entry that you kind of submit will be put into a random shuffle, and we'll pick one entry from there. Cool. I do want to introduce kind of one final thing, which is the upcoming DEVS events. So this week we have kind of the mentoring intro, where you get kind of paired up with the exec member and you can ask questions. We also have industry night next week, I believe. We have interviewing and CV. And the next tech workshop we have is AI and machine learning. So these are all awesome workshops to attend. So yeah, that is kind of the conclusion of Coding 101. Thank you all for attending. We went slightly over time, but that's fine. It's been kind of a great time. Hopefully you learned JavaScript, its fundamentals, and what it's all about. And if you want more details about the competition, feel free to kind of stick around. I'll kind of go through the different tasks. Yeah, so sweet. In terms of the competition, the details and the hints are around here in the README. We'll be posting kind of a link to submit your solution soon. And then from like a week from now, we'll kind of pick a winner according to kind of the entry process that I described before. Awesome.
Thank you.
No problem. Thank you all for attending.
Thank you, guys.
Yeah, thank you guys.
Good stuff. Good stuff, guys.
Awesome.
Awesome.
Holy shit, sorry, Simon. That was so my bad.
Oh.
No, wait, was it?
So here's what happened. Like Alan just DM me like a chat to kind of like skip to objects, and I misread it as like skip objects, and that's why it happened. But yeah, it's also my bad. Like I was like just skim through. Okay, skip
Oh,
object.
I was like, oh shit, I'm gonna use object.
That's unlucky. Yeah. Hopefully that was all clear. About the competition, I think we do have to kind of submit a link, and I'll talk to marketing about it. But
Yeah.
I guess it'll be like a week from now.
Sorry to bother you guys. I was wondering,
Oh, yeah.
when Pac-Man eats between 5 and 10 pills, do we pick how many pills that is, or is it a random number between 5 and 10?
So it should be for the entire between 5 and 10. So if he eats 5, 6, 7, 8, 9, and 10 pills, he should have that ability to eat ghosts. Before 5, he shouldn't be able to eat ghosts. After 10, he shouldn't be able to.
Okay, so it just loops pretty much. After each 10, it's like a reset day.
Yeah, I guess kind of. That's one way you could approach it. You could kind of utilize that handle ghost Pac-Man eat method and do some
Okay.
trickery there. But that's completely up to you.
Thank you very much. Much appreciated.
No problem.
Great job. That was pretty on time.
Yeah.
Yep.
Yeah. Oh, it's still recording. Cool. I guess we can process it. We'll post
Okay, I'll
that up.
stop my recording.